All right, so absolute value of 9, either -9 or +9 works. In general, with your absolute value equations, you should expect you're going to get two answers. Whatever's inside the absolute value could be a positive number or it could be a negative number, but then when it goes through the my absolute value signs, it becomes positive because it represents distance from 0. So when we look at something like the next problem, I've got 5x plus 7 inside my absolute value bars. 5x plus 7, that whole quantity, could equal what two numbers? And make this a true statement. 5x plus 7 could either equal 42 or it could equal -42. And whether it equals 42 or -42, once we calculate the absolute value, we get 42 out. So what we're going to do is we're going to split this equation into those two cases. Once you have the absolute value alone, there's nothing added, subtracted, multiplied, divided by it. We're going to say what's inside it, 5x plus 7, and that's going to appear twice. What's inside will never change. Even if it was a negative or a subtraction, you're just going to carry that down exactly as you see it from the absolute value. And then we're going to set it equal to the same number we see on the right and the opposite of the number we see on the right. So this is accounting for both things that can happen. Either what's inside is 42 or what's inside is -42. And then it gets +42 at the end once we calculate the absolute value. Now you're just going to solve these two little mini equations. So in both of them, you're just going to subtract 7 and divide by 5. So if I do that on the left, I end up with 35 divided by 5 gives me 7 is my first answer. For the one on the right, subtract 7, -49. Divide by 5, just keep that exact fraction. -49 over 5 would be the second solution. Can I check those answers? Yes, you can plug them back in, make sure they work very easily, just like any other equation we have. All right. Bless you. Let's try this one. The absolute value of 4x plus 6 over 5 equals 6. All right, so in this one, my absolute value is alone. So we can go ahead and split it into the two cases that can happen here. Either 4x plus 6 over 5 equals 6, or 4x plus 6 over 5 could equal -6. And then when I calculate the absolute value, I get 6. How do I solve for x? What's the first step in each of these? All right, so get that 5 out of the denominator, multiply by 5. 30 and -30. And then in both of them, we're going to subtract 6 and divide by 4. So on the left, I'm going to get 24 divided by 4 is 6. On the right, -36 divided by 4 gives me -9. Plug them back in, make sure they work if you want. Okay? All right. Let's try this one. -2 times the absolute value of 3x minus 4 minus 5 equals -27. So this one's a little different because I don't just have an absolute value on one side. I've got some things added, subtracted, multiplied by it. So what we're going to do first is get the absolute value alone before I split into my two cases. So how do I get the absolute value alone here? What would you do first? Add 5. Think of it just like you would with the parentheses. Move everything to the other side. Add 5, that gives me a -22. Then divide by -2, which gives me 11. My absolute value is isolated, so now you can split it into the two cases. Either 3x minus 4 equals 11, or 3x minus 4 equals -11. In both cases, we can add 4 and divide by 3 to get our final answers. On the left, I get 15 over 3 is 5. On the right, add 4, that gives me -7 over 3, -7/3. Any questions on this so far? Okay. So what happens if I have not just a number on the other side? So we have absolute value of 7x plus 2. That's alone. That's good. But it equals 4x plus 11. As soon as that absolute value is alone, no matter what the other side looks like, you're going to be able to split it. The absolute value, what's inside it, 7x plus 2, does not change. We're going to apply the same strategy we did when there was just a number there. In one case, we're going to set it equal to exactly what we have, 4x plus 11. In the other case, we're going to set it equal to the opposite of what we have. And when we say opposite, we mean put a negative in front of it. So negative, parentheses, 4x plus 11. You could also, if you wanted to, all in one step, just distribute that negative through. So pretty much changing the sign of everything on the other side. That's how we split it. And now you just solve the mini equations that you created. So on the left, I would subtract 4x over. That would give me 3x. I would also subtract 2 to the other side, giving me 9. So x equals 3. On the right, I need to distribute, if you didn't already. So negative 4x minus 11, the opposite of what was on the right side. Add 4x, that gives me 11x. Subtract 2, gives me negative 13. And then divide by 11. Negative 13 over 11. Okay. We're going to do one more. Maybe. What if there's two absolute values set equal to each other? If this happens, it is equivalent in solutions to dropping one of the absolute values. So this equation will have the same answers as the original equation. Or you could drop the absolute value around the x plus 3 and keep it on the x minus 11. Doesn't matter which one. Once you do that, it ends up looking like the previous problem now. We're going to split it. X plus 3 stays the same in both. On one equation, I keep what I have, x minus 11. On my other equation, make it the opposite. So negative, parentheses, x minus 11, or do it all in one step, distribute your negative through. On the left here, if I subtract x on both sides, what's going to happen? They're going to cancel, so I'm left with 3 equals negative 11. Is that possible? No. So that piece is not going to give me any solutions. It doesn't mean the whole thing has no solutions. It just means we're probably not going to have a second answer here. It might just be one. On the other side, distribute my negative. Negative x plus 11. Add x, that gives me 2x. Subtract 3, that gives me 8. X is 4. And then this one's really easy to check. If I plug it on the left, 4 plus 3 gives me 7. If I plug it on the right, 4 minus 11 gives me negative 7. And the absolute value of those would be the same. They would both be 7. So real quick, easy, plug it back in, make sure it works. You can do that when you're doing your Math Excel too. Save yourself a little bit of time. All right, now this is not on here, but I want to just talk about this problem. Let's say I have the absolute value of 5x plus 7 equals negative 10. What do you suppose the answer to that problem would be? It is no solution. Why is this different than the other ones we did? The absolute value equals a negative number. Now, can there be negative numbers in my problem? Yes. But once the absolute value is alone, it can never be equal to a negative number because we know anything that comes out of an absolute value is either 0 or a positive number, right? So if you see something like this, don't try to split it. You're going to get false solutions. It is just no solution as soon as you have an absolute value compared to a negative. All right, the last 4 problems are quick. They are yours on your big idea worksheet to try. Here they are. I'll give you guys a few minutes. I'll put the answers up. We'll check them and then we're done. Negative 3/2 and 15/2.
Yes.
Number 5, did you get no solution?
Yes.
6, 1/2 is the only answer that works. It's a quick one to plug back in. Make sure you get a true statement. And 7, I got 5/4 and 3/2. How do we do? Good. All right, that's my little mini lesson, absolute value equations. Yes?
Why was 5 the next 3 halves? Is it really a negative?
It's because once you get that absolute value alone, it's equal to a negative number. Yeah, you can split it and you can get 2 answers, but if you take those answers and plug them back in, they will not work. Other questions, guys? All right, you have about a half an hour now to work on Math Excel. 3.5 Math Excel is due tonight if you have not finished that lesson. This lesson, 1.5, 1.7, is due on Friday. So you can work on either of those right now. And then tomorrow we'll move on to the next topic. I'll do the cell phone lotto for you.